Okay, it looks like it's top of the hour. Thank you everyone for joining us today for our webinar. Just a couple quick things before we get started. Your questions can be submitted through the questions pane throughout the webinar, and we'll try to get to those at the end. And your certificates will be available on Friday by logging into your account. And an evaluation will be emailed to everyone at the conclusion of the webinar today. Dr. Meyer, if you'd like to get started, go right ahead.
Thank you, thank you, thank you. It is my pleasure to be here with everyone today. I've been looking forward to this because I have a lot of new information to share. And as you know, my challenge is going to be getting it into the time that we have allocated. So today we're going to be focusing on the evidence and best practices to increase the use of mother's own milk in the NICU. And within that, I want to prioritize the focus on secretory activation, or as many of you refer to this early first 2 weeks of lactation for mothers who are breast pump dependent. So first, just in the way of disclosures, I'm not going to read these in the interest of time, but I've separated the research and demonstration projects for which I and my team have been funded through our work at Rush University, as well as my personal payment for presentations and consultation, so that everyone is aware of any potential conflicts of interest. So as far as presentation objectives, I have 4, and I want to first focus on why does this first 2 weeks matter? And it matters because there's new evidence that mother's own milk is even more superior to donor human milk than we knew in the past, and I want to share some of those data. Secondly, I'm going to summarize the physiology of secretory differentiation, activation, and coming to volume. Third, we're going to focus on the utility of mother's own milk biomarkers of secretory activation in the management of lactation for NICU moms. And this is an area of research that I and my team are actively involved in right now. And finally, we're going to focus on strategies for prioritizing lactation practices. So number 1, evidence. So I think the first thing to do is to be sure we're all on the same page with respect to definitions. So oftentimes people will refer to human milk to mean mother's own milk, donor milk, some mixtures of it. And when we focus on the data about mother's own milk versus donor human milk, it's really important that we understand what we are talking about. So mother's own milk, or as I refer to it in the presentation from now on, MOM, is shown in numbers of studies, whether it's fresh or frozen, is typically fortified, reduces prematurity-specific complications and their costs in a dose-dependent manner, and promotes adequate growth. However, the beneficial outcomes do not extend to pasteurized mother's own milk. And I realize that most of the countries now, mother's own milk isn't pasteurized, but in some instances it is, especially in some areas of the world. And when we talk about the benefits or the outcomes of mother's own milk, it doesn't extend to pasteurized milk. Donor human milk has been shown repeatedly to reduce necrotizing enterocolitis in every study that's been done, but it does not reduce sepsis, bronchopulmonary dysplasia, nor neurodevelopmental problems, and is associated with slower growth. Then we come to this area that's called human milk. Human milk, by definition, is when infants, and it's probably the most common way we feed babies in NICU, it's a combination of mother's own milk and donor human milk. But the concern when we read papers is that the benefits of mother's own milk are often generalized by investigators or clinicians to donor human milk through this slippery slope that we call human milk. And I have some new studies on human milk today that I'm going to share with you. And then finally, the exclusive human milk diet usually refers to no bovine protein. So it would be human milk, which is either mother's own milk or donor milk or a mixture, and a human milk fortification. So that's for clarification, so as we begin. So I think most of you are familiar with the work that our team has done over the last 10 years that began with our Love Mom cohort, or the longitudinal outcomes of very low birth weight infants exposed to mother's own milk. And this began with our observational cohort of 430 infants. And over the course of this grant, we've reported the use of mother's own milk, reducing necrotizing enterocolitis, sepsis, bronchopulmonary dysplasia, neurodevelopmental problems at 20 months corrected, and healthcare use after the NICU hospitalization. This was with mother's own milk. We did not use any donor milk in this study, so babies either got differing doses of mother's own milk or formula. Furthermore, these relationships were dose dependent in that the higher the dose of mother's own milk, or the more exclusive that feeding of mother's own milk, the greater the reduction in these various complications. What might be of interest to those of you, though, that always think about the costs associated with what we've done, our most recent paper, for which Dr. Johnson, our healthcare economist, took the lead, was just published in Pharmacoeconomics. And this was a cost effectiveness study that looked at the costs of our what was at that point our Rush Mother's Milk Club program, including the breastfeeding peer counselor salaries, and took all of those things into a cost effectiveness model and still showed the effectiveness of mother's own milk in reducing costs for very low birth weight infants in newborn intensive care. So there's no question about the effectiveness of mother's own milk. However, what I want to target a bit today is some of the newer data that really is moving in the direction of mother's own milk as personalized medicine. And some of these studies are done with healthy full-term babies. Some have been done with premature babies. But overall, what the data are showing is that mother's own milk is becoming increasingly personalized with respect to the taste and the smell, for example. And that has been shown to be something that is noticed among premature babies as well. The microbiota is unique to the mother, mucosal immunity to microbes, tolerance to environmental antigens, and there is a programming effect on developing organs. So two of the studies that I think are among the most fascinating, we often talk about skin-to-skin care in newborn intensive care, especially for the smallest, sickest premature babies, and how important that is. Because that's really the mechanism, not just by which babies become more stable when they're held by mothers in skin-to-skin care, but also by the fact that they tend to seed the mother's skin and respiratory surface with antigens in the NICU environment. And then through this pathway, which starts the maternal gut, we have individual cells at home to the mammary gland and become secretory IgA that are secreted into the milk that the mother then makes for her baby, personalizing the immune response to the infant's NICU environment. And then the other one that I think is just fascinating is this paper that has conceptualized the breast as the bridge between the gut of the mother and the gut of the baby. So increasingly what we're seeing is more and more data that show this one-on-one, or if it's twins, I suppose, 1-to-2 interaction between the baby and the mother, so that the milk is increasingly personal to optimize the baby's health and development. Just a couple of examples that I think illustrate the way this direction is going. So, you know, in the newborn intensive care unit, I think probably everyone has started using mouth care or oral care, whereby we put the mother's own milk in the infant's oral cavity. We know that there are many mechanisms by which mother's own milk is thought to be protected via this route. One is cytokine absorption by the OFALD system. One is the barrier protection by the oligosaccharides of mother's own milk. One is the mother's own milk microbiome that actually seeds the mucous membranes with healthy commensal bacteria from the mother's milk. But what is really interesting is that there is an even synergistic reaction between what the infant does in response to the milk, because the milk actually contains an amylase, xanthine amylase, and when it combines with salivary xanthine in the infant's oral cavity, we get a much more powerful antimicrobial response than what could be measured in the milk before it is fed to the baby. So this, I think, is a fascinating thing that we're beginning to see more and more. It isn't just what's in the milk that we can measure before we use it or we feed it. It's how it interacts with the infant's structures to be able to have an even more synergistic impact. And by the way, this is one of the education sheets from the Provide compendium that's available, as I mentioned earlier, on LactaHub. Another example of the bioactivity in milk and how it's so easily underestimated or underappreciated by simply measuring pre-fed milk is the study that is shown here. And one of the things that was so fascinating about this is that the investigators measured, using proteomics, measured the bioactive proteins, which are in green, in the pre-fed mother's own milk, and then digested the milk and measured the peptides that were released as a function of the digestion, and found, and this was called the peptidomic part of the study, and found an additional set of 60 peptides that were not in the initial proteome that was in the pre-fed milk. And the majority of those peptides were focused on immunologic and immunomodulatory functions. So again, this is, I think, a good example of the personalization of mother's own milk that we don't see with donor human milk. So from a scientific perspective, there really is not a substitute for mother's own milk in very low birth weight infants. So just to recap, we see a dose-dependent reduction in the risks, the incidence, and the severity and costs of all of these different complications, as well as a stimulation and programming of the development of immature organs and pathways that are especially important for the very small premature babies who have these majorly underdeveloped, some brain, lung, eye tissue. Again, just pointing out, trying to bring a lot of things in here for both the clinicians and the researchers involved. One of the grants that I mentioned on the in the disclosure is a grant that I received from the Family Larson Rosenquist Foundation to create a toolkit to translate the evidence about mother's own milk in the NICU to clinical practices and best procedures to use. Those materials are available free of charge to be downloaded and used at lactahub.org, as you see here. But one of those is, and they're intended to standardize messaging, they're intended to be used by the practitioner to educate the families about the different components of milk and removing milk and feeding milk. But this one I think is especially interesting because it does take into consideration all of the different things I just mentioned. And the focus isn't so much on milk as a food, but the focus is on the immaturity of the infant's body organs that increase the risk of potentially preventable complications of prematurity, and details which specific components of the milk reduce the risk of these complications, and as well clarifies that only mother's own milk, not donor milk and not formula, can stimulate these different developmental processes for the baby. So we'll leave that and now go to this phrase that truly makes me crazy. When mother's own milk is not available, the solution is donor human milk. So I pulled this slide together for a webinar that I did recently for World Health Organization about donor human milk, because it is just common in the research. Almost every paper on donor human milk starts this way: when mother's own milk is not available, as if that's acceptable. So I think the question is, why is mother's own milk not available? that is really the crux here. Isn't that we automatically substitute it with donor human milk, but we have to understand why the mother's own milk isn't available. And donor human milk shouldn't be the solution for the lack of evidence-based practices that increase mother's own milk in the NICU. So let's take a second here and look at the new status of donor human milk. So I've listed several of the, I would say, more common, the Cochrane review, the individual studies that I think are particularly compelling, that show that donor human milk once again reduces NEC, but doesn't have an impact on the other morbidities. Donor human milk results in slower growth unless it's super fortified, and sometimes even then we still get poorer growth. And donor human milk doesn't reduce NICU costs despite reducing NEC. Now, I want to pause here for a minute as I go into the next slide, because I have heard myself quoted by other people as saying I am anti-donor human milk, or I'm against donor human milk. And I don't have any personal relationship or feelings about donor human milk. I do want to support the data, and it is important to recognize that donor human milk has an important role in newborn intensive care because of its reduction of necrotizing enterocolitis. I think where I have issues with it is that there are many people who are such strong proponents of donor human milk that we see the outcomes of mother's own milk generalized to it in a way that staff members don't understand the difference, mothers don't understand the difference, and that I think is taking the benefits of the donor human milk beyond what the data show. So let's spend 1 second. Why does donor human milk reduce NEC? Well, it's probably because of what's not in it. In other words, there's no bovine protein in it. We know from several studies, and I reviewed them in the paper that you see here, and that cites all of these individual studies for this first comment. But we know that formula upregulates inflammation in the gut, it increases intestinal permeability, and actually destroys gut epithelial cells. All of those things increase the risk of NEC. So the formula feeding is really increasing the risk of NEC. Donor human milk doesn't contain bovine protein, and the data, as well as I think the years of experience with donor human milk, we've come to see it as a safe alternative to formula so we can start feedings earlier. By starting feedings earlier, then we get the byproduct effect. Earlier enteral feedings, we reduce NPO times, we reduce TPN times. TPN is separately inflammatory as well. So the sooner we can have babies onto full feedings and without a line for feeding and without TPN, then we reduce the risk of sepsis. So what we see is, again, donor human milk has a very important role, but it isn't because of what's in it, it's what is not in it. So I've summarized here some of the newer studies that are beginning to inform limitations of donor human milk. And a couple of these, some are related to pasteurization, as you see here, but there are a couple of them, and in fact, it's the center two that I want to look at in a bit more detail, because these studies actually looked at donor human milk versus mother's own milk. So if you take a peek at the slide here, this is the Ford study that was published a couple of years ago in American Journal of Clinical Nutrition. This study enrolled 125 very low birth weight infants, and the babies were divided into two cohorts based on what proportion of their exclusive human milk feeding was donor milk versus mother's milk. And what I want to point out here, all of the babies in this cohort were fortified with a human milk derived fortifier. Now, this group, what we see is this group of babies received greater than 50% of their feedings as mother's own milk, and there were 74 of them. And this group received less than 50% of their feeds as mother's own milk, and there were 43. But keep in mind, this was an exclusive human milk group, so the other feedings were donor. Now, I think even more interesting, and this is what a lot of us see, is that it's not like there's an equal distribution. The mean dose of human milk, mother's own milk in this group, was 91% of feeds were mother's own milk. And for this, it was 14%. So you basically have a comparison of babies that were fed exclusive mother's own milk versus donor human milk for a fairly long period of time. Well, what these researchers showed was better growth velocity, higher final weight, fewer episodes of feed intolerance, and greater gut microbiota diversity. On the other hand, what the data showed was that the babies who received mostly donor milk were more likely to have weight below the 10th percentile and head circumference below the 3rd percentile, and found within this group that there were 2 times more extremely small head circumference measures. There was more BPD in the donor human milk group and a higher incidence of what they called composite severe morbidity. So this will be combining the sepsis, the BPD, and the necrotizing enterocolitis. So this, I think, is one of the very telling studies that teases out this whole exclusive human milk and why, if people don't report the varying doses of mother's own milk versus donor milk in this human milk diet, it's easy that one of the effects out just basically covers the other. So we don't really see, when it's just exclusive, how much of that was attributed to mother's own milk and donor human milk. So the second study was actually done very similarly, a smaller number of babies, but different measures involved, because this was really a mechanistic study that was published just a couple of years ago. So this study enrolled 40 babies that were both very low birth weight and very preterm, and they were again divided into 2 cohorts. One group of babies received greater than 80% of their feeds as mother's own milk, and the other group received greater than 80% of their feeds as donor human milk. And again, this was observational, but all of the babies got exclusive human milk. This was an ambitious study, collected milk, urine, stool specimens, and looked at microbiota and metabolic interactions. Compared to mother's own milk, donor human milk showed alterations in milk microbiota, altered carbohydrate synthesis pathways in the milk samples, altered steroid biosynthesis pathways that was confirmed not only in the milk but in the urine, showing an effect on the infant metabolism, altered pyrimidine metabolism, again in the milk and in the urine, which is concerning because the pyrimidine metabolism is related to neurodevelopment in infants. And the researchers concluded that the different compositions in mother's own milk and donor human milk and feeding of donor human milk impacts the metabolic phenotype on microbiota. They posit a role for the steroid hormones in mother's own milk that are attributable to some of these changes that we see in metabolism that are altered in donor human milk. And they posit again that it may partially explain differences in clinical outcomes. So I'm going to leave this body of work for right now. I hope I've made my case that we're definitely looking at the superiority of mother's own milk versus donor human milk. So when we say mother's own milk is unavailable, we really should have a very high bar as to thinking, why is that the case and what we should be doing about it. So moving into our second objective. So throughout the world, what we see is that the continued provision of mother's own milk for premature, very low birth weight infants remains a problem for, especially even in the United States, where we look at racial and ethnicity among our mothers, despite very high rates of lactation initiation. So in most NICUs, certainly in the US, our rates of initiation are actually higher than for healthy mothers and babies. So very, very high rates of initiation, but that doesn't translate all the way through to going home from the NICU getting mother's own milk. We know from our own studies that mothers don't meet their own self-stated goals for mother's own milk provision. And I actually had to pull at the last minute. I have a lot of data on goals for Black and non-Black mothers in terms of some of the national data and quality improvement initiatives. But in the interest of time, I had to pull those. But I do want to simply say that in our work, when we did these studies, and we have about a 54% Black versus non-Black population. And the reason I refer to Black and non-Black versus white and minority is because that's really where the difference is nationally, is that the Black mothers are significantly less likely to continue providing milk for their babies. The Hispanic mothers actually provide milk at rates very comparable to white non-Hispanic mothers. So our mothers that we really are concerned about are our Black versus our non-Black mothers. But those mothers actually had the same goals. All the mothers had the same goals. It was just that the Black mothers were less likely to achieve them. The primary reason that we see is that the mothers run out of milk, and the timing often coincides as the infant is beginning to need more milk because the baby is improving, which is somewhere usually around 4 to 6 weeks. So this comes to why is this first 2 weeks important if mothers seem to have enough milk in the 2-week period, but they run out at 4 to 6 weeks? Well, this is why it's important to understand the biology of early synthesis of milk and secretion. And our goal is to develop point of care testing to identify and manage risk, which is what takes us into these biomarkers. So our work and that of others really show that this first 2-week period of time is a critical window with respect to long-term lactation outcomes. And our data from our 430 Love Mom mothers showed that the primary predictor of babies going home still receiving their mother's own milk was whether or not the mothers had achieved coming to volume, or 500 milliliters of milk per day, by 14 days postpartum. This was a stronger predictor than maternal race. It was a stronger predictor than any of the sociodemographic characteristics we often think of. So therefore, that is an important quality improvement measure, is do mothers reach this point at 14 days? Well, at 14 days, if you take a peek here at the diagram, at 14 days, what we know, if we take a peek here, is that the breast is making and secreting milk, and that the milk is removed by a baby breastfeeding or by the pump. Now, if we're talking about the pump, and not a baby who's breastfeeding, this is where we get into this mismatch, because milk removal has two purposes from a physiologic point of view. It assures adequate intake of the infant, but it's also critical for regulating lactation processes. So the breast is only going to make milk if the milk is removed, as we've learned about supply and demand. And this first 2-week critical period is that time that it's so important. So this is where this mismatch occurs. And that's why it's so important that parents understand, that staff understand, the baby at the end of 2 weeks in the NICU may be taking as little as 100 milliliters of milk a day. That would be adequate intake. But if the mother is going to regulate lactation processes and continue to make milk so that there will be milk at the time the baby goes home from the NICU, we're really looking at least 500 milliliters a day. So this is the mismatch. Mothers think, well, as long as the babies are getting enough milk, then my process is fine. And the nurse taking care of the baby thinks mother has extra milk, everything's going well. Mothers often think, well, as my baby needs more milk, I make more milk, which is true with a healthy full-term baby, but not when the pump is the entity that is controlling lactation, as opposed to the baby's appetite. So let's take a quick look here at the physiology of secretory activation and coming to volume. If we start with secretory differentiation, what we know is under the different pregnancy hormones, the breast undergoes a tremendous change. We see a growth in secretory cell number, ductal branching, but mother's own milk synthesis is held in check because progesterone, which is secreted by the placenta, is present in very high concentrations, and progesterone is an inhibitor for prolactin's ability to synthesize milk. Prolactin has a role, again, in preparing the breast to breastfeed, but it does not synthesize, it doesn't stimulate the synthesis of milk due to progesterone. At the time of birth, the placenta delivery triggers secretory activation because it removes this inhibition of progesterone. And that's when we see the beginning of secretory activation, which is also referred to as lactogenesis 2 or the milk coming in. There's an upregulation of pathways that synthesize milk components. There's a closure throughout the breast of one paracellular pathway that allows back and forth movement between the breast and the blood. And what's really critical here is that stimulation by the infant or the pump is essential for optimal secretory activation. Now, to get a perspective on what an amazing organ the breast is, if we look at what happens in terms of maternal milk volume in this first few days post-birth in healthy mothers and babies, what we see is that studies show that very little milk is consumed from the breast in this first 24 hours. In fact, the best study that I think was ever done on this was the study, the Santoro study, where it was shown that 15 milliliters of colostrum was the average amount of milk consumed in the entire first 24 hours by a healthy full-term baby. And that translated into 10 to 11 feedings in the first 24 hours to transfer that small volume. However, if you look at what a miracle the breast does, the mothers of those same babies are producing anywhere from 500 to 600 milliliters of milk by days 4 to 7. So what happens that this miracle occurs that we go from such small amounts of milk to these copious volumes? Well, what I want to show you here is some of the physiology and the biochemistry and the milk product with respect to secretory activation. So just as a bit of nomenclature, this is an individual cell that secretes milk in the mammary gland. This is the lumen of the duct. So what the cell makes would be secreted into the lumen. This is during pregnancy and the lead up to secretory activation. And this is once secretory activation is achieved. Now, key to all of this is that the paracellular pathway, so that's what you see here, there are little spaces between the cells, and the paracellular pathways during early lactation allow a back and forth movement between what is in the mother's bloodstream and what is in the milk itself, because what is in the mother's bloodstream can pass directly into the milk. And that's what we see, for example, medications, high molecular weight medications can transfer more easily during this period of time. This is why we see colostrum, because all of the different high molecular weight maternal antibodies go through. But once those pathways are closed, as you see here, it stops that back and forth movement. Now, why is that important for lactation, and what can we do about it? Well, the first thing is that one of the main components of milk that is secreted for nutrition is lactose. Lactose, because of its osmotic properties, once it's secreted by the individual lactocyte, it readily crosses back into the maternal circulation because of osmotic properties and is excreted in the mother's urine in such a way that the use of 24-hour urinary lactose measures was an early measure of secretory activation some years ago, before we developed other ways that were less cumbersome for the mother to be able to collect samples for us. So this lactose going back into the circulation causes a real problem, because lactose is the main osmotic driver of milk. So lactose has to stay in the gland because it pulls in all of the liquid components of milk that are responsible for milk going from 15 milliliters on day 1 to 600 milliliters on days 4 to 7. So in this early period of time, lactose goes back into the maternal circulation. The other thing that is significant, though, not so much from a nutrition point of view, but more from a biomarker point of view, is that mother's milk, or mother's serum sodium, actually crosses readily into the colostrum product during this period of time, again, because of osmotic gradients. So not only does the cell make sodium, but we get sodium in from the maternal circulation. So colostrum, as many of you know, is a very high sodium milk. Okay, so then what happens when these paracellular pathways close, as they do with continued stimulation to the mammary gland, either by frequent infant suckling, breast pump use, and under the stimulation of prolactin? What happens is they close, lactose stays in the gland, it pulls in the liquid. The sodium chloride is now reduced in the milk significantly because there isn't this source coming in from the maternal circulation. So we get the low sodium typically that we think of in breast milk. So now, in explaining all of this, I didn't look at anything that I had written here, but I think what I focused on was covered everything that we have written, but secretory activation actually necessitates the closure of these pathways. So this is when we talk about secretory activation, that's a key part. One is, of course, activation of the cell, the components that are made that make milk. So it's the upregulation of the milk making machine. And the other one is the closing off of the paracellular pathways. So we'll come back to secretory activation, but just to define coming to volume. Coming to volume is the control of lactation processes as they change from this hormonal mechanism I just spoke to becoming autocrine and paracrine regulated. And this, I think, if you really look at what is happening to the breast during this period of time and what is happening to mothers of healthy babies that they're breastfeeding and NICU babies, it's no wonder that this is the time that is the most fraught with mothers thinking they don't have enough milk, real or perceived, and the high numbers of mothers that stop breastfeeding during this time. Because what we see is a switch from what you just saw that's hormonal. And now we have two different mechanisms, completely different from what was in place before, that are regulating the milk volume. So that we want to make certain that we remove as much of the milk as possible during this period of time. Each breast operates as a separate entity during this time. So this is common if we see a breast that's had a piercing, or more commonly in the NICU, if we see a mother that might need two different size breast shields on the two breasts. The one that's missized, we can see less milk coming from that breast because of the fact that the breasts are not being equally stimulated, and the down regulation of milk supply occurs at the individual breast. The alveolar membrane at this point is very sensitive to milk stasis and works to downregulate prolactin. And there are two major mechanisms that are controlling what we would call coming to volume, or this change from the endocrine to autocrine. One is the suckling-induced prolactin surge, and I'm sure probably many of you who followed my work have seen this diagram for 25 years or so I've been using it, but I think it explains so well. A mother who is breastfeeding is going to have a baseline prolactin level, but that baseline prolactin level beyond the period of secretory activation is not going to help her make milk. That baseline prolactin level must be stimulated by milk removal and the stimulation of suckling at the breast or pumping. Because what happens with the baseline, so if we have a baseline pumping, a baseline prolactin level here, so I'm sorry, prolactin on this axis, and then minutes after the onset of suckling here. So this is when the baby goes to breast or pumping begins. And what we see is a peak prolactin that occurs somewhere between the first 30 to 45 minutes after the onset of suckling, and then gradually returns to baseline. So we get a very powerful suckling-induced prolactin surge during this period of time. And it's the area under the curve when milk synthesis is the most rapid. So that's why we say that there's always milk in the breast, that as the milk is being drained from the breast is when we see the milk replenished most rapidly. Now, over the course of 2.5 to 3 hours, roughly, the prolactin concentration will return to normal or to baseline. So the mother needs another pumping or breastfeeding, so that over the course of the day, we see repeated suckling-induced prolactin surges. Now, as a quick aside, the way that the different galactagogues work, the prescription galactagogues, is that they inhibit dopamine, which allows a higher baseline prolactin. So instead of a mother's prolactin perhaps being 50, it might be 150. But it has no impact on the surge. The surge is only from infant suckling at the breast or pumping and the removal of milk. Just a diagram. Again, some of this literature is classic. It's older, but it couldn't be repeated today. So these are studies where mothers actually had a catheter inserted for blood draws and show the pre or the baseline prolactin and the peak prolactin. And the point I want to make here is that that peak in comparison to the baseline is the highest in early lactation. So we're looking here the first 10 days. So the breast is really primed over this period to be able to support the needs of the baby in making an adequate volume of milk. So as this remains one of the mechanisms for sustained lactation all the way through for as long as a mother breastfeeds. But the highest difference between baseline and peak is during this period of time. So this is why we want to optimize the not just the frequency of milk removal, but the optimization. It has to be effective. If the pump pressures aren't the right thing, if the shields don't fit correctly, we're not going to optimize prolactin. So it's not just pumping frequency. So the second mechanism is this autocrine-paracrine regulation. And it's basically a function of milk left behind in the gland. Now, for years, we thought this was the feedback inhibitor of lactation, which is a milk protein that, when left in the breast, works to downregulate the sensitivity of the alveolar membrane to prolactin. And that is still considered one of the mechanisms. But there are many other mechanisms now that I'm going to show you in this diagram and come back that have been proposed as far as local factors regulating milk secretion. So certainly the milking frequency is one. We see a role for insulin growth factor 1. We see a role for apoptosis. So many of these different things now have been implicated, much of this being informed by the dairy industry. But nonetheless, we think that it's not a single mechanism anymore, but the catalyst is still a breast that is not well drained. And what I want to have us think about with this population of mothers is that we think of weaning when a mother consciously decides, okay, it's time I'm going to wean my baby. But mothers in the NICU are inadvertently weaning as their milk supply decreases or declines. So we're really looking at a weaning mechanism for these mothers if we allow this, this phenomenon of not removing all the milk adequately to perpetuate. Okay, now we've described the secretory differentiation, activation, and coming to volume. Okay, where are the milk biomarkers? Well, back to this slide. The milk biomarkers are simply sampling milk over the course of this transition from the time the mother gives birth through the time that the paracellular pathways are closed. And it's a very, very simple concept when you think about it, because what we're actually measuring, now I shouldn't say that, because depending on what we measure, we can measure a number of milk biomarkers. And in some of our earlier studies, we measured lactose, we measured citrate, we measured total protein, we measured fat, and we measured sodium and potassium. Of all of those, the measures that seem to be the most informative, at least for the most for most mothers, and I'm saying it that way because I do think other transcellular pathways such as citrate may be involved, for example, with mothers that have inflammation or high BMI. But the majority of mothers, we can simply look at milk sodium, because as we look here, the milk sodium from the mother's circulation into the milk gradually decreases as we see those paracellular pathways close. So it will go from what is coming from the mother's circulation to a lower value that's what's in the milk itself. We could do the same thing with lactose, and some researchers have, but lactose is a much more difficult component to measure at the bedside. So our work has really focused on looking at milk sodium. And I should go back here 1 second, because researchers have looked at sodium in and of itself as a biomarker, but some also have looked at sodium-potassium ratios as a way of simply standardizing the sodium so that we get a ratio that's like a 0.8 or a 1.0 or a 1.2, because we know predictably how potassium is going to increase about the time that sodium is decreasing in the milk, so we get a certain standardization. But researchers have used both just plain sodium as well as sodium potassium ratio. So I'll point you to the fact that we became interested in looking at this, I believe it was about 2015 when we wrote our first grant. And we were interested in looking at biomarkers as a way of looking at whether early hormonal contraception interfered with a mother's ability to lactate if she was pump dependent. And we decided, okay, well, we really don't want to look at these things as she's still making milk 2 months later, because what's really going to be interrupted with early hormonal contraception is going to be secretory activation. So that was really the basis for our being involved in this. So we have a series of papers from our different studies right now. And I added a couple. Leslie Parker and her group in Florida have done some great work on this too. And Alana Chertak and her group have focused on the diabetic mothers looking at milk biomarkers. So, but everything is based on the principle that I just showed you back and forth between the blood-breast barrier. So quite simply, the one reason sodium right now is attractive to do, as potassium is as well, is that we simply need a milliliter of milk. We measure it daily, either for sodium or sodium potassium ratio, and it can be done as a point of care bedside test. We incorporated this into a recent study that's called Making Pumping Better for NICU Moms. And we were fortunate with this study in that we worked with Medela engineers, and I attribute this specifically to Judy Janes. Many of you know her, who did a lot of back and forth in designing what we call our smart pump. So the smart pump obliterated, or that's not the right word, allowed us to not rely on maternal milk logs. The smart pump had a chip, a computer chip, that recorded total number of minutes pumping. And we studied mothers over a 14-day period of time, so that each day we could calculate how many times the mother pumped, how many minutes she pumped, what was the longest interval between pumping, whether she was using the initiation or the maintenance pattern, all of those different things that were available in a computer chip. We also worked with engineers to make a little scale. So it's a gram scale that weighed to the nearest 10th of a gram, and designed an app so that the mothers were actually able to weigh the milk that they had pumped separately from the right and the left breast using this app, and that was recorded in the computer chip for the pump as well, so that we have a very sophisticated set of data for the 35 mothers that were enrolled in this study. So I just want to share with you what the future may look like in terms of what we can do with these data. So just a bit of nomenclature here. The blue, okay, let's start first with the axes. This is postpartum day 1 through 14. This is milk removed in milliliters. And this is the duration of pumping, actually in hours, to be able to fit it easier on the graph. Okay. This is the amount of milk removed in blue, the duration of pumping, again in hours, in pink. This black line is the sodium potassium ratio, and typically anything under 0.8. If we look at the literature that exists with term mothers and babies, and it's primarily research literature, we look at the achievement of secretory activation. And across the top, we see the frequency of pumping that day. So let's take this chart and we look, as many of our mothers, we don't really have a pumping. Oftentimes the mothers may have tried to pump on day 1, but they're often very sick and they really get into it by day 2. So what we see is that the mother got very small amounts of milk, but pumped a fairly decent number of minutes. And then over the course of the first several days, we're able to see that the mother really did a lot of pumping, got more milk each day, okay? But that pumping she did early on paid off in the second half of the 2-week period by pumping less, as you see here, and getting more milk. So that alone, we've taken and put into one of the education sheets for the family, for the Provide compendium. So mothers realize that this isn't the norm. You're not going to be pumping 2 hours a day and getting 100 milliliters of milk the whole time. That's going to change. So we put this into an education sheet. But this is the sodium potassium ratio. So again, anything under about a 0.8 is considered secretory activation. This couldn't be more textbook picture perfect. But we see, the mother's achieving secretory activation typically here between day 5 and 6, not on day 2 or 3, like a mother of a healthy baby. And she maintains that sodium potassium ratio all the way through, making milk, coming to volume. So this is a perfect textbook one. However, 2 of the mothers in our study, actually it was more than 2, but I'm just showing these examples, really demonstrated a lack of permanence for things that commonly come up in the NICU. So without going through all of the details again with these 2 graphs, I just want to tell you quickly what had happened. So this mother quickly achieved secretory activation, had so much milk stored, didn't really want to pump, decided that she was going to decrease her pumping, told the nurse at the bedside that she didn't want to pump anymore. She had stopped pumping. And then one of our research staff went to speak to her. The nurse spoke to her and told her how important her milk was going to be for her baby. So as you can see, the mother fell out of secretory activation, reinstituted her pumping, and came right back in. This was a mother that is typical in that she was very, very sick and had retinal detachment, partial retinal detachment with her baby's birth. And this day that she'd been pumping along and making progress with secretory activation, this particular day she only pumped once because she was in the doctor's office the entire day waiting and having procedures done. And as such, popped out of secretory activation, again with encouragement, came back, began providing her milk again. And as you can see, we see secretory activation here. Now, this is an interesting one because my PhD student, Clarissa Medina Polenes, actually looked at the increase in milk volume daily over the course of the first 14 days for mothers with BMI of 27 and above versus mothers with 27 below 27. And what I want to point out here, and I'm getting close to time, so I want to just show you, you can run away with it here. The mothers that were in the lower BMI group basically increased the daily amount of milk they pumped by 64 milliliters a day versus 34 milliliters a day by the mothers with the high BMI. So at the end of that at the end of the 7-day period, the mothers with the lower BMI produced 393 milliliters of milk on average, whereas this group of mothers made about half of that. But what was equally alarming is that in the second half of that 2-week period, we really saw no changes. There was just a plateau, which make us think that, okay, well, maybe this critical window doesn't go to 14 days. Maybe this critical window really needs to target this first 7 days. So now finally, strategies for prioritizing. Okay, well, first of all, we know that secretory differentiation itself may be impaired by morbidities that affect our NICU mothers. And I think it goes back to, to this, with looking at high BMI being one of the inflammatory morbidities. There's a lot of speculation and a lot in the animal literature that when the breast develops during this period of time that is characterized by inflammation. So we look at the mothers with pregnancy-induced hypertension, overweight and obesity, diabetes, other metabolic syndrome kind of complications. The animal data really show that we see a difference in gene expression for prolactin signaling and receptors during this time. And the point I want to make to get past this and onto our priorities is that what we think may be secretory activation problems with mothers probably has some origins in secretory differentiation. We don't have good measures to know which is which at this point. That's something I think has got to be a huge research priority, because I think many of the mothers we may be dealing with, what we have in our toolbox of skills may be inadequate to really help some of those mothers really achieve what we would think of as full lactation potential. Okay, let's go to best practices. I'm not going to spend a lot of time on these because I want to have at least a minute or two for questions. So obviously prioritizing resources in this first 2 weeks. Now, when I say proactive lactation care, that means we don't wait for the mother to come to us and say, I'm having problems. We know what those early problems are from all of the research that's been done. I've listed different examples here that I think people want to think about. This is a time that we should see each mother each day. And to the extent that mothers can be watched while they're pumping to be sure they're doing everything correctly during this first 2 weeks, each day until we know it's done the right way, for me, it would be a standard of care. Now, we've had some success assigning the NICU lactation nurse super user to babies so that they can work with mothers during this critical first 2 weeks, and prioritizing that these nurses teach other nurses, especially our new orientees. Optimizing pumping behaviors and skin-to-skin holding. The pumping behaviors, again, seem to be critical if we really look closely at the data in this first 5 days. We know our mothers are sick during that time. We know that it sometimes feels hard to ask them to pump. It's difficult, but the reality is that this is from the data. It seems that's when we have to really prioritize pumping frequency, effectiveness, and efficiency. We want to avoid hand expression only protocols. This is really, really important during this period of time because the data have shown that the hand expression does not work comparably to a breast pump because it is expression. It's a completely different mechanism than suction, and suction is what is necessary for the stimulation for prolactin. Best practice also includes implementing the Provide Compendium Toolkit to standardize practice, message with families, and to do quality improvement. I've listed the contents of the Provide Compendium. If you're not familiar with it, again, visit the website. Everything is available free of charge to download. I had a little typo on your handouts with the summary. This isn't anything about a mermaid, which was something that I had overlooked from another presentation. But the summary, I think I've gone through the importance of mother's own milk, the limitations of donor human milk, the strategies to optimize mother's own milk, and highlighting this critical first 2 weeks, as well as summarizing best practices. So I'm going to stop now. I hope we have time for at least a couple of questions. So I'm going to put the video on.
Thank you, Dr. Meyer, for that amazing presentation. I love your view on donor human milk. That is amazing. We do have about a minute to take some questions. There are a couple in the chat or questions panel. The first one is, could you please tell us what LOVE stands for again? That was in slide number 7.
Yeah. We call it our Love Mom cohort because, you know, all cohorts have to have a name. Love Mom means longitudinal outcomes of very low birth weight infants exposed to mother's own milk.
Great, thank you so much.
Mhm.
The next one is thoughts on fortification of EBM with formula.
So don't think you mean using formula to fortify? So I'm wondering if maybe this is after discharge, because typically we wouldn't be using formula to fortify human milk during the NICU stay. We would be using a bovine or a human product. So I think this probably goes to my question. I think it would probably be after NICU discharge. Um, Personally, I think that the data really show that not all babies are going to need additional milk or fortification of anything, any kind, when they first go home, if they're gaining weight adequately and growing on mother's own milk. So that I think would probably be worthwhile to have as an individualized decision as to whether babies are given, part of the milk each day as a formula. I think this really has to be thought about very carefully. Many people will say, well, let's be on the safe side and make sure the baby has all the minerals the baby needs. And then the other argument would be, well, let's be on the safe side and make sure we need to replace mother's own milk when all the studies on outcome show that it's dose dependent. So we're reducing the lifetime dose to the baby. So I think there are two different ways of looking at the fortification guidelines there.
Thank you. I know we're a little past time, but do you have time to answer one more question?
I do, as long as
Okay.
people are able to stay on.
Okay. This one I think was a good one. I am a NICU nurse. I am a NICU nurse of 6 years, soon to be an IBCLC. My NICU does not have a dedicated lactation consultant for our NICU. What can I do to help our unit create a NICU lactation staff group?
Okay, now this is a really, really good question, because I feel that what I've done in the last 20 years of my career is to create the evidence that people like this person can use to be able to articulate the need for someone. So what I would recommend is that you look at this most recent paper by Dr. Johnson, because the paper really argues from the point of view of an administrator, is what is the economic justification? Because the barriers for this are always going to be, we don't have enough money. There isn't the resource to do this, but there's the resource for the donor milk. So donor milk is expensive. Donor milk is nutritionally inferior. And the evidence has to evolve, or using the evidence, I guess, has to come from this whole idea that that it may be a position change in the short term to bring on a lactation consultant to be able to secure or acquire more mother's own milk. But at the same time, then you're offsetting the donor human milk. You're providing the baby's nutritional, a much more superior nutritional product, and you're reducing the likelihood of morbidities. So for me, it would be taking the argument that economically, mother's own milk in both the short and the long term is going to benefit the babies, and we'll see lower costs.
Thank you, Paula, for that answer. I knew you would like that question. Your NICU does such a great job with that. We are past time. I appreciate you, Dr. Meyer, presenting that great information once again to us. Just as a reminder to everyone, evaluations will be sent out via an email at the conclusion of this webinar. So make sure that you fill that out. We'd love to have your feedback. And also by filling out the evaluation, we can provide you the 1.0 nursing contact hours for attending today, and certificates will be available Friday by downloading those off your account, excuse me. And visit medilaeducation.com to register for our April 20th webinar. Have a great afternoon, everyone. Thank you again, Dr. Meyer, for presenting for us. Thank you.
My pleasure. Thanks to everybody.